Hello, hello. Hello, 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 hello. Hello, amazing people. How are you all? My name is Ayush, and I'm here for you again. All good? Having fun? Namaste, namaste. Good evening. This is our second class of recursive series, right? Some amazing type of series to learn and some good questions to solve. You know, this is good to learn. You'll get to get a lot of confidence over math, right? A lot of confidence over pattern, basically, right? A good mathematician, always we say, uh, is the one who is observant, a lot observant. Very observant people are good mathematicians also. Like, you should be able to pay attention to the detail. Okay, when you'll grow up, no, and you'll go for interviews or college examinations or many things, first thing of the first thing they'll check inside you, or the first quality they would expect from you would be to be observant, to be a good observer, right? So last class we learned about arithmetic progression. We started learning about arithmetic progression. We learned how do we write a common term of any type of series. We learned uh, how do we generalize a series. Sir, can you give the proof of sum of first n terms of AP? Definitely, Shreyansh, we'll do that. We'll do that. Okay, don't worry. We'll do everything. Okay, now let's. So we saw a lot of type of sequences, and then we jumped on to arithmetic progression, which is a very commonly known and which is very useful arithmetic progression. All right. So now we know that Tn, we'll get this formula, guys. We'll get this formula which is written so for sum of n terms. We'll get it with a lot of means, right? Stick with me. You'll get to learn a lot today. Now, general term of any arithmetic progression. What is arithmetic progression? In which there is a first term and there is a common difference. What happens? We keep adding the difference, right? So terms are like this: a plus 3d, right? Just like this: 3, 7, 11, 14, 17, 21, like this. Okay, first term is 3, common difference is 4. So 3 plus 4, 3 plus 8, 3 plus 12. Oh, sorry, wait, did I make a mistake over here? 3 plus 4, 11, 15 would be here. 15, 19, 23, right? So this is a plus d, a plus 2d, a plus 3d, a plus 4d, a plus 5d. What is d? D is over here is 4 and a is nothing but 3. This is what we learned in our last class. Remember? Sir, from Alan, missing you. Are nice. Nilajit? Uh, great. Thank you, man. That's a good thing about a teacher. This is the most gratified thing we find in this job or this career, that our students do remember us. Anyway, come on, let's see. So A and D, understood, right? This is how it works. So common term, any general term, A plus n minus 1 into D. This is what we learned, correct? This is what we learned. What is A over here? First term of AP. D, common difference. A and D can be anything, right? Real numbers, any real numbers. N has to be a natural number, right? N is the term, for example, of this series. If I want a sixth term of this series, so sixth term will be T6 will be 3 plus 6 minus 1 into 4, right? So 23 would come. You can see that. This is what we learned. Now let's understand what if we have to add the terms. Okay, first term is A again, right? Second term is A plus D. But now this time I'm not separating them with commas. I'm going to use this A plus D, then A plus 2D, then A plus 3D. This is how I'm going to add these terms. Are you getting the point? A plus N minus 1D till some general term. I don't know what is N. I don't know what is N. Sir, which center did you teach in Alan? I've taught at many centers, bro. Sikar, Kota, Bangalore. Chodo na, leave it. That's not the topic right now. Leave it. Even out of India. Okay. Yeah. Okay. So A plus D, A plus 2D, A plus 3D, A plus N minus 1D. This is what we write the sum as, right? These are the terms. Okay. n is, I don't know what is n. N can be 10, 20, 50, 30. N has to be a natural number, obviously, because number of terms will be natural only. So sum of n terms, this is what we have. This is how we are going to write. Now what am I going to do is, I'm just going to write the same thing but ulta. Why? I'll just change the order of these things, and how magically something good will come out. How? See, if I write first term as a plus n minus 1d, I'm writing it ulta, I'm writing from there. Second term would be a plus n minus 2 into d, obviously. Correct? No? No? Second last term, what will be second last term? N minus 2d, no? Do you get this? Correct? Second last term will be n minus 2d. Yeah, sir, no problem. We can understand. A plus n minus 3d would be your third last term. No problem, sir. This is what it is going to be. So, see, in this series itself, if I do n minus 2d, right? So, 6 minus 2 would be 4, 4 into 3, 4 into 4 would be 16, 16 plus 3 would be 19. So, this term would come, second last would come, right? You can realize it like that, n minus 2d. So, now, like this, chalte chalte, we'll have a plus d, and last term would be a, right? Last term would be a, correct? No. Now what am I going to do? You see, now I observe that yaar, over here, bro, there is something good. There is something which I can use if I club these terms. Look at this. I'm adding the first term with the last term, second term with the second last term, third term with the third last term, right? Fourth term with the fourth last term. I don't know fourth last term, which one is that? But last term, I'm going to add with the first term. But how did I get this idea? Why did I get this idea? Sir, who told you that, how would a person would come up ki yaar ulta likh do? We'll write it ulta and the terms will add up and some formula will come. First, let's see what's happening. Okay, first let's see what's happening. Why are we writing ulta and what benefit is it giving us? Right? So this side, if I add, I have two equations, same thing only. No, I can double it. I can add this side. If I add everything up, this side I'm getting 2 times of sum of n terms. Right? You understand, right? Sn means sum of n terms. I'm representing this sum as sum of n terms. Tn is a term, general term. Okay, 2 times of sum of n terms would be equal to, what is this plus this? Sir, this is 2a plus n minus 1 into d. No problem. What is this plus this? Just check. A plus a, 2a, d minus 2d minus d. Okay, so again I'll get nd minus d, that means n minus 1d, right? 2a plus n minus 1 into d. Correct? What is this plus this again? A plus 2d plus a plus n minus 3d. This will also come out as 2a plus n minus 1 into d. All these sums. In fact, the last one also, 2a plus n minus 1 into d. Magical, right? Amazing thing. So now what is this? Okay, this is same thing getting added with itself. How many times? We have n terms. So this same thing is getting added to itself n times. N times it is getting added to itself. Correct? So sum of n terms. Now, okay, I'll write 2 times sum of n terms. So say if you add 4 100 times, it will be 4 into 100. If you add 10 20 times, it will be 10 into 20. If you add 1 n times, it will be n into 1, that means n. If you add the same thing n times, how will you write that? How will you write that, guys? N multiplied with this same thing, 2a plus n minus 1 d. You got your formula. Sn, sum of n terms is nothing but n divided by 2 multiplied with 2a plus n minus 1 into d. Wow. Correct? You got this. How simple? Nothing we did. But the question still remains the same. No, divide both sides by 2. Yeah, divide both sides by 2, or you are just simply taking this 2 because this is in multiplication over the left side. So you are taking it or in the division over the right side. Nothing major you are doing. Okay, but you are making a formula for sum of n terms of a sequence, of a recursive sequence, which is AP, where first term and common difference is there. Correct? Right? Getting my point, guys? But again, my question remains the same. How this idea came? How this idea would have come? And what is this idea telling you? Now, this same formula I can write one more way. Right? I have 2a, no? I have 2a. I have twice of a. So I'm going to write n by 2 and I'll split this a as a plus n minus 1 into d. 2a was there, so I write it like this. Now, why did I do this? Because I realized that this thing is nothing but any general term. This was the formula for any general term, right? Tn. So yes, correct. You guys are, if you are thinking what I'm thinking, then you are correct. N by 2 multiplied with a plus. Now, some people think that this is a plus l, last term. Not last term, I would say. I would say any term. Suppose Tn, write it as Tn over here. So suppose if we are finding sum of 20 terms, okay, if we are finding sum of 20 terms, we are coming to it, Darsh, AGP also we are coming, okay, just hold on, okay, understand this thing very carefully, because this formulas, this derivation is telling you a lot of things. It is a lot of things which this formula is going to tell you. How? I'll tell you. See, you realize n by 2 into a plus tn. Now, if you are finding sum of 20 terms, it will be 20 by 2 into a plus t20. T20 cricket wala nahi. T20 means 20th term. Okay, T20 means 20th term. If you are finding sum of 100 terms, then it will be S100 will be equal to 100 by 2 into first term plus 100th term. Okay, learn it like this. Understood? Now again, coming back to the question, how this idea came. Now when I look at that any AP, if I look at any AP, no, if I look at any AP, I realize that yeah, this particular term and this term, if I add them up, I get 26. If I add these two, also I get 26. I get these, add these two, I get 26. Oh my God, this is how I realize that I can derive a formula for sum of n terms. Why? Because equidistant terms in any part of the AP. Achha, chalo tell me, if this AP, it has 100 terms. If this AP has 100 terms, 6 terms will also make an AP, na? If I take a part of AP, that will also still be AP, right? If I take a part of arithmetic progression, it will still be arithmetic progression. So any part you can take, that will still be arithmetic progression. You realize that equidistant terms are always the sum of equidistant terms are always equal. If I write some more terms, 3, 7, 11, 15, 19, 23, 27, 31. Okay, if I do this, then also this thing is same. Equidistant terms. 3 plus 31 is 34. 27 plus 7. 34, 34, 34. Equidistant terms, the sum of equidistant terms in arithmetic progression will be same. And this is how I realized, arey yaar, I'll just write it ulta. What's the problem? Okay, I'll just write it ulta. What's the problem? I'll get sum of n terms formula. And then comes a question. Try this. This came in mains. Okay. Now, for this question, one more information you'll require. What? Sir, one more thing we need to observe about AP. Okay, one more thing we'll need to observe about AP. Suppose if I write just terms like this, a plus n, a plus d plus a plus 2d plus a plus 3d, or let's say like this, a plus d, a plus 2d, a plus 3d, okay, a plus 3d, a plus 4d also I'll write, no problem, a plus n minus 1d. Okay, this is an AP, right? These are the terms of an arithmetic progression. I realize that. Now you see, one more thing you can notice. What, sir? What will be sum of n terms? We just now realized, sir, it will be n by 2 multiplied with 2a plus n minus 1 into d. Correct? Okay. Let's 3. Some terms also I'll write so that you'll realize very better, right? 11, 15, 19, 23, 27 and 31. Okay. Now you see, if you add 4 terms, how much is it? 15 plus 11, 26, 26 plus 7 would be 33, 33 plus 3 will be 36, right? Sum of 4 terms is equal to 36. Sum of 3 terms is equal to what? 7 plus 11 plus 3. That means 21. Okay. What if I do sum of 4 terms minus sum of 3 terms? What am I getting? 36 minus 21 equals 11. Sorry, 15. Right? Do you realize that? Sum of 4 terms minus sum of 3 terms is 15. That means S4 minus S3 is giving me 4th term. Why is it happening? See, if you add 4 terms, right? If you add 4 terms, sum of 4 terms will be, sum of 4 terms would be, in this formula also if you will do the same thing, no, sum of n terms minus sum of n minus 1 terms will always give you the nth term. This is the formula. This is what I'm trying to tell you. If you get the sum of 10 terms minus you do the sum of 9 terms, you'll get the 10th term. Obviously, bhai, if we are adding, suppose how many terms are there? 3, 3, 6, 8. If I'm adding 8 terms, till here I'm adding, till 31 I'm adding, and I'm subtracting the sum till 27. Which term I'm going to get? I'm going to get 31. That means if I add sum of 8, if I find sum of 8 terms, and from that if I subtract sum of 7 terms, I am going to get the 8th term. So sum of n terms minus sum of n minus 1 terms will always give you the nth term. Amazing. This is also beautiful. This is also something which we can realize, and we can derive this also. We have Sn formula. Just in this formula only put S of n minus 1. So you'll get this form. Okay, you'll get same formula. Nothing, no problem. Directly you'll get the same formula. Right now, yeah. Okay, it is saying sum of n terms denote the sum of first n terms of an arithmetic progression. Okay, Sn denotes the sum of first n terms of an arithmetic progression, and it is saying that sum of 10 terms is equal to 530, and it is saying sum of 5 terms is equal to 140. Okay, it's just equation solving. Can you find S20 minus S6 for me? Can you find S20 minus S6? Yeah, Shreyansh. Can you find S20 minus S6 for me quickly? What would you need? Sum of 10 terms, you'll put 10 by 2 multiplied with 2a plus 10 minus 1. That means 9 into d. Correct? N minus 1. So n is 10. Then you'll do S5 equals 5 by 2 multiplied with 2a plus 5 minus 1. That means 4d. Not a big deal. Okay, this is also 5. Right? This is given to you as 530. This is given to you as 140. You'll just solve and get your answer. So from here, at what are we getting? 530 divided by 5. 10s are 53, 106. 106. So you'll get 2a plus 9d is equal to 106. And you are going to get 2a plus 4d is equal to 18. Oh, 28. Sorry. Right? You'll just subtract it and find d. Subtract both the equations and find d. You know how to do it. What will be d? 5d will be equal to 106 minus 28. All right. Can you find your answer? A is equal to what? Come on. Okay, 78 by 5 will be your D, and then A is going to be, as Shreyansh is saying, 8. Correct? This should be your answer. 1862. Most of you said the same answer. Correct, 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 correct. Not a problem. Arey, D is 10. Did we do a mistake? 106 and we didn't do anything here. We solved it. Acha, 5 by 2 it was. 280 by 5. So 280 by 5. Here we did a mistake. 280 by 5 it will be, no? 56. Now it's correct. 5D is going to be, D is 50. D is your 10. D is coming out to be as 10. Right? If D is 10, then 106 minus 90, 16 will be your A. 8. 8 will be your A. Right? You got A and D. Now you can do anything about this. S20 minus S6. Again, you can find with the formula. Right? Understood? Correct, 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 correct. Any problem? See how easily we could solve this question. just a simple manipulation of some formula, and we could solve an easy question, right? This was definitely an easy question. Now the thing is that let's move on to a different type of question. Just a minute. Okay. Let's try and do this. How many more days will sequence and series finish it? I think 2 more classes max. All right. Sum of n terms. Realized? Understood? Now, this is saying in a sequence Sn is given to you. Sum of n terms is given to you. Then find the nth term of that sequence. For a sequence where Sn is given to you. Now, first question which should come into your mind is, sir, how do we know that it is arithmetic sequence or arithmetic progression? Obviously, that question should come into your mind. Yes or no? Sir, it's written for a sequence. We don't know which type of sequence, no? We don't know which type of sequence. Do we? Do we? We don't know. Obviously, we don't know. Okay? Do you know? We don't know. But we recently found a formula for sum of n terms of an AP, n by 2, multiplied with 2a plus n minus 1 into d. Now, in this same formula, if you see, if we take n common, then we have 5n plus 3. And 5n plus 3 can be a general term of an AP only, arithmetic progression only. Why? Because a general term of an AP will always be linear and sum of n terms of an AP will always be quadratic. The formula, the expression for sum of n terms of an arithmetic progression will always have a degree 2. That means it will be quadratic. Understood? Remember this. Sometimes they might give you directly sum of n terms of a sequence and it will be written like this, something like this. You have to realize that, yeah, if it is quadratic, then definitely AP, right? And in this also, this particular thing, 5n plus 3 is the general term. AMG, everything, bacha, everything will study. Okay, this is the general term. 5n plus 3 thing, no? This is your general term of that particular AP. Okay, this is how you know, right? So by looking at the expression only, you can say, yeah, this is an arithmetic progression sum of n terms formula. And if they are asking you to find the nth term of the sequence, then we also know one more thing, that Tn is nothing but Sn minus Sn minus 1. Sum of n terms minus sum of n minus 1 terms. So Tn will be nothing but, in the same formula, 5n square plus 3n is my sum of n terms. What will be sum of n minus 1 terms? 5 into, instead of n, I'll just replace it with n minus 1. Sum of n terms, sum of n minus 1 terms. What's the problem? Right? So this ka square plus 3 into n minus 1. And when I solve it, I'll get the formula for Tn, and definitely it is going to be linear. Okay, we can check also. This is what, 5n square plus 3n. Okay, let me write it here only. So this will be 5 into n square plus 1 minus 2n plus, okay, 3n to n, 3n minus 3. Okay, so now 5n square plus 3n minus 3n gone. This will be 5n square minus 5n plus 10n plus 3n minus 3. 3n gone, 5n square gone. This is nothing but 5n minus 3. 5n plus 3. Here minus became plus, no? 5n plus 3. You see, that's what we realized. We could have given it directly. The answer could have been given directly over here. N common, 5n plus 3. Correct? है ना? बोलो, yes or no? Yes. Are we clear? Direct answer we could have given if the formula is written, if some expression of Sn is written. We got our marks. All right, Ji. All right. Okay, one more thing, and then we'll talk about what if a sequence has common terms, because they can ask you about common terms, questions on common terms also. Before that, an easy question again. First and last term of an AP are 1 and 11. If the sum of its term is 36, then the number of terms will be equal to what? Wow. It's an easy peasy. It's an easy peasy, yes or no? First term and last term are given to you. Sum of 11 terms will be equal to what? Sum of 11 terms I taught you. It will be equal to 11 by 2. Two formulas we learned. 2a plus n minus 1d, and first term and last term. That means T11, 11th term. That's why I'm saying, remember this formula like this. So sum of 11 terms is nothing but 11 by 2 multiplied with first term is given 1 plus T11. T11, 11th term. Okay, 11th term. T11 is given to me. Alright. And sum of first and last, first and last term are 1 and 11, and sum of its 36 terms. If the sum of its 30, if the sum of its terms is 36, not 36 terms, sum of its terms is 36. That means 11 terms are only there. If they are saying last term is 11, so do we know that have I written it correctly? Whatever I have written. Acha, of last question. Have I written it correctly? Can you tell me if this is correct or not? According to the question. Again, read the question. First and last term of an AP are 1 and 11. And the sum of its terms is 36. I don't know how many terms, so I have not written it correctly. I'll write it again. Sum of n terms is nothing but n by 2 multiplied with first term and nth term, last term or nth term. Okay, this is what I know, right? This sum of n terms is given to me. I don't know what is n right now, but sum of n terms is given to me. First term is also given to me. Last term, that means this nth term is given to me. 11. Last term, that means this nth term. If last term means nth term, T11 only. Correct? So this is given to me 11. Now, have I written it correctly? 36 is equal to n by 2 multiplied with 6n. So n is equal to 6. 36 by 6, that is 6. So it's just that you have to interpret your question correctly. Okay, it's very important. Right? Last term means nth term. How many terms? I don't know. Okay, last term. Last term given to me is 11. Right? Chaliye. Let's go ahead. Now, suppose something like this. Sum of n terms of two arithmetic progressions are in ratio 3n plus 8 and 7n plus 15. Find the ratio of their 12th terms. Now see, how will we solve it? They are saying sum of n terms of two arithmetic progressions. There is AP and AP dash. Let's say two arithmetic progressions are there. AP and AP dash. Two brothers with a different hairstyle maybe. Okay. So AP and AP dash are there. And the ratio of n terms, sum of n terms. Ratio of sum of n terms. So sum of n terms of first AP, this AP, and sum of n terms for the dashed AP. Both n terms only. 20, 30, but in both 20 terms ratio or in both 30 terms ratio or in both sum of 50 terms ratio. Sum of n terms ratio is given to me. This is given to me as 3n plus 8 divided by 7n plus 15. You see? Okay. Now what is sum of n terms? I know n by 2 multiplied with 2. Let's say capital A is the first term of the upper AP and small a is the first term of lower AP. Okay, so 2a plus n minus 1 into, let's say, capital D is the common difference of upper AP, right? In both n terms sum only we are finding. So this will be 2a plus n minus 1 into D. Small d and small a are the first term and common difference of the lower AP, dashed AP. Okay, n by 2 obviously will get cancelled because sum of n terms only we are talking about. Right? Correct, G, correct. Okay, now let's see. So 3n plus 8 divided by 7n plus 15 comes out to be equal to 2 times of a. Can I write it like this? I'll divide by 2 also, no? In the numerator and denominator, do you mind? I'll write like this, n minus 1 by 2 into d, capital D, divided by a plus n minus 1 divided by 2 into small d. Not a problem. What's the problem? What are they asking us you to find? They're asking you to find the ratio of their 12th terms. That means T12 and T-12, the two APs. The ratio of their 12th terms. Ratio of their 12th terms they are asking. Oh, small a over here. Ratio of their 12th terms they are asking. You realize that? Okay. And what do we have? We have this. What will be the 12th term of this AP, the upper AP? T12 for the upper AP will look like this, a plus n minus 1 into capital D. And for dashed AP, the term will look like this, a plus n minus 1 into small d, because this is the general term, right? This is the general term. N will be 12, so it will become a plus 11 capital D divided by small a plus 11 into small d, right? This is what I want over here. Do you know Arjun Sen sir from Alan Pune? Na bacha, I don't remember. I've never been to Pune, Alan. Okay. Understand T12, T-12, A plus 11D and small a plus 11D. Can I create it over here by putting some value of n? Can you create same thing? Can you create a plus, I'll write more neatly, 3n plus 8 divided by 7n plus 15, right? This was there, no? 7n plus 15 is equal to a plus n minus 1 divided by 2 into capital D divided by small a plus n minus 1 divided by 2, complete division by 2 into small d. What do I need? I need T12 divided by T-12. T12 will be capital A plus 12 minus 1, that means 11, into capital D divided by T-12 will be A plus 11 into small d. Now you tell me, I want this on this side. If I get this on this side, I have my answer. So what should I put as n so that I can create this? So that I can create this. Obviously, n is equal to 23, sir. Put n is equal to 23 and you are sorted there. If you put n is equal to 23, you have to put n is equal to 23 everywhere. So 3 multiplied with 23 plus 8 divided by 7 multiplied with 23 plus 8 will be equal to a plus 23 minus 1, that means 22. 22 divided by 2 will be 11 into capital D. Small a plus 23 minus 1, 22. 22 divided by 2, 11 into small d. This is what I wanted. This is what? This is T11 divided by T-11, isn't it? And I have a numerical answer over here. 69 plus 8, 78 divided by, what will this be? 2 7s, 14, 3 7s are 21, 161 plus 8, 169. Something like this. Calculate again to check. Okay, you got how to do? All right. Okay, let's go ahead. Now, about common terms. Sometimes common terms also we can get. Right. Now, it's very simple to understand that if there are two APs, these are two APs, 3, 7, 11, 15, 19 is one AP. It is going like this. And 1, 6, 11, 16 and 21. It is going like this. Now, whenever this happens, that why do you put n is equal to 23? Acha. Why did you put n is equal to 23? Here, na? Oh, yeah. Beta, what did I want? I wanted to create this ratio. I wanted T11, the 11th, 12th term, the ratio of 12th term of upper AP and lower AP, these two APs. This is what I wanted. Find the ratio of their 12th terms. So if I wanted the ratio of 12th term, that would look like A plus 11D upon small a plus 11D. I wanted 11 with D. So I just put, I solved n minus 1 divided by 2 should be equal to 11. In this case, what will n come as? N will come as 23. Na? Wouldn't the numerator be 77? 3 3 9, 3 2 6, 68, 78? 77. 69, 78 only. 70. Acha, ye, this, yeah. Okay. I told, right? Check. Sir, I came just now. Don't we put 2n minus 1 instead of solving it? Huh? Where? Okay, ji? Clear now? 77. जो भी calculation you guys do. Now common terms. If common terms start occurring, you just know. See, common terms are there, right? You can see the common term. No, 11 is the first common term, for example. Now, if we stretch this AP 7, 11, 15, 19, 23, 27, 31. Okay. Here also, if we stretch it, difference is 5, 5. Right? 11 plus 5, 16, 16 plus 5, 21, 21 plus 5, 26, 26 plus 5, 31. So, second common term also we can see now. Right? If we keep writing, we are going to get common terms. Are you sure? Right? We are going to get common terms. Definitely, we are going to get common terms. If we are going to get common terms, we should know that, see, now if we write the common terms, first will be 11, second will be 31. Can you tell me what will be the third one? What will be the third common term? Can you see? Can you tell me? What is going to be the third common term then? This is how it is going to be like. Obviously. 51, 71, 91. Why? Because you see, here also, this is also an AP. A is equal to 11 and D is nothing but equal to 20. This is also an AP. What did we understand? Hello, Aditya. What did we understand? We understand that, yaar, if common terms occur in two different APs or three different APs, the common terms will also form an AP. Definitely. And the common difference of the common term AP. What is the common difference here? 4. What is the common difference here? 5. The common difference of this common term AP will be the LCM of common difference of the 2 or 3 APs, how many ever you have. Nothing but the LCM of 4 and 5 is 20. Correct? So they are asking you 10th common term of this AP. So 10th common term of this AP will be T10. T10 of the T10th term of common terms AP. That means 11 plus 9 into 20. 191. Correct? Getting my point? Yes or no? You see this? Yeah, we have covered basics. One class also, one more class has happened already. Dekho, 3, 7, 11, 15 till 403 this AP is going, and another AP is 2, 5, 8, 11 till 404 this is also going. Till 404 this AP is going. Now they are saying be the two arithmetic progression, then the sum of common terms in them is equal to. Sum of common terms in them will be equal to. Obviously, these are two finite progressions. We know till where they are going. These are two finite progressions. Are you sure? Correct? Do we understand? These are two finite, limited number of terms. Na? So 3, 7, 11, 15. Right? Next, we know we have used this AP a lot many times. Right? So now there should not be any problem. Okay. Let's write a couple of more terms. Here, this one 2, 5, 8. Okay. So first common term we have is 11. Second common term is 23. Okay. So common term AP, with this let's call it CTAP. Common term AP will be 11, 23, 35, 47. Correct? Correct, no? What is D over here? D1 is nothing but 4. What is D2? D2 is nothing but 3. So our common term AP is going to have first term as this and common difference as 3. Sum of the common terms in them. How many terms? But we need to know how many terms are there. By sum of common terms, till where are they going to go? Till where these terms are going to go? That's the question. So this AP is going till 403. This AP is going till 404. Can there be a common term more than 403? No. Can there be a common term which is greater than 403? No, obviously no. If the last term is common and it is 403, we'll check. We'll check. How do we check? We know that if 403 is the common term of this AP, we'll check. A plus n minus 1 into d. We have A and D both, right? So I'm going to write 403 is nothing but equal to 11 plus n minus 1 into difference is 4 into 3. That means LCM of 4 and 3, that means 12. And I'll solve this. I'll see what is n. I'll see what is n. Okay, so I'll solve. I'll say 403 is equal to what? 11 minus 12. That means minus 1, 12 and minus 1. 12 and minus 1. And from here I get 404 divided by 12. Now you tell me, is this a natural number? Is this cancelling? 2 6 are 12, 101, no, 202. 101 by 3 is not a, okay, not a natural number. But that, what does this mean? If n is not a natural number, this means that 403 is not a term of this AP. But whatever is the common term, okay, it will be below this. What is the value of n over here? Calculate. 33 point something. What are we getting? 33 point something. 2b is equal to a plus c लगा लो. अरे ठीक है. Yeah. What is the value over here? 33 point something. Come on, tell me. 33.3. N is nothing but equal to 33.3. That means this AP has 33 terms. That means my common terms AP has just 33 terms, which is right below this. Only 33 terms can be there because 403 is coming at 33.3. That means this is not a term. This is not a term, but terms are ending only at 33rd term. So this AP, which is 11, 23, 35, common term AP. This is my common term AP. Correct? This is my common term AP. This has how many terms? This has 33. This has nothing but 33 terms. So I'll find the sum of 33 terms. So 33 divided by 2 multiplied with 2 into 11. You can find the 33rd term and apply A plus L, or just simply do this. This will be your answer. So 2, 3, 5 aren't consecutive. When did I say 2, 3, 5 are consecutive, bacha? 2, 3. 11, 23, 35. This is common term AP. 32.66 आ रहा क्या? Let's see. 33 आना चाहिए. 33 it should be. 33 it should be. Yeah, it should be 33 only, right? Correct only. Correct, no? Understood? 33 terms are going to be there. Nothing else. Okay, okay. Right? Now, let's move on to next thing. Let's just revising our key points which we need to remember for AP. Common terms of two AP form an AP. Yes, we know. Right? If we multiply every term of AP with a constant, if we multiply K to every term, this will also form an AP. If we add or subtract a fixed thing, a constant thing in entire AP, in every term of AP, that will also form an AP. Okay, that will also form an AP. If I have 3, 4, this one, 3, 7, 11, 15, this AP, if I multiply every term with 3, let's say, or 4, so that will also form an AP. No, multiply with 4, 12, 28, 44 and 60. This is also forming an AP. Difference is 16. Okay, so if you multiply every term of an AP with a fixed number, fixed real number, that will also form an AP. If you add or subtract something, a constant thing from an AP, The resulting series will also be in AP. Sum of terms equidistant from beginning and end is same, very important property. Okay, suppose if you have to choose sometimes, now this thing is, suppose you have to guess or assume, suppose you have to assume terms for uh, doing some question. Suppose you want 3 terms to be in AP. For example, something like this, right? That digits of a positive integer having 3 digits are in AP and their sum is 15. The number obtained by reversing the digits is 594 less than the original number. Then find the number. Okay, so in some cases, sometimes you need to assume terms in arithmetic progression. Now suppose if I assume like this, a plus d, sir, assume, that means okay sir, no problem, 3 terms, any 3 terms of AP will be like this, a term plus difference plus 2 times difference. Okay, this is what's going to happen. But if I'm adding these, right, suppose what is it saying, the digits of a positive integer having 3 digits are in AP and their sum is 15. Okay, so let's say these are the 3 digits, let these be the digits, right, let these be the digits. So when I'm doing a plus d plus a plus 2d, this should be equal to 15, correct? So this is 3a plus 3d is equal to 15. That means I get a plus d is equal to 5. Okay sir, sorted. There must be some more information given to solve. The number obtained by reversing the digits is 594 less than the original number. We know how a number is formed, right? If a number has digits a, b, c, then number is formed. 524. How do we form 524? 100 into 5 plus 10 into 2 plus 4 into 1, right? So a, b, c are the digits, then number will be 100 into a plus 10 into b plus c into 1, correct? This will be the number. If a number is there, suppose 736 is the number, so 100 into 7 plus 3 into 10 plus 6 into 1, correct? That's how we form a number, no? By 631, how is this formed? 100, if digits are 6, 3 and 1 in this sequence, 100 into 6 plus 3 into 10 plus 1 into 1, by unit place, tens place, we have learned this. If I want to form 136, then it will be formed as 100 into 1 plus 10 into 3 plus 6 into 1, right? This is how I will form the number. So if my digits are these are my digits now. So how will the number will be formed? 100 into a plus original number in this sequence. If this is the sequence of the digits, 100 into a plus 10 into a plus d plus a plus 2d. This will be the original number. Reverse number, this is original number, and reverse number will be what? 100 into a plus 2d plus 10 into a plus d plus a. This will be the reverse number, correct? This will be my reversed number in the reverse order. But yeah, this got too complicated. 2 equations I'm eventually going to get. A plus d is equal to 5, and another information is the number obtained by reversing the digits is 594 less than the original number. That means this number is this minus 594. This is equal to, curved equal to. Okay. But yeah, how much complication will solve? So one more thing, that is why we say whenever you have to guess. Okay, I hope you understood this. I was just doing this to prove my point. Whenever you have to guess, whenever you have to guess 3 digits in AP, right? Whenever you have to guess 3 numbers in AP, let the 3 numbers, or in this case, let the 3 digits be a minus d, a and a plus d. Choose it in a way so that you can solve your question more efficiently. Why? Because now when you are doing sum of digits, a minus d plus a plus d, right? And when you are putting this equal to 15, what is happening? You are now no, one more thing. See, this is AP only. A plus d minus a, d. A minus d, d. Right? A minus d, d. So whenever you have to choose 3 numbers in AP, choose it like this. What should be the rule for choosing the numbers in AP? What should be the rule? Rule should be that there should be a common difference. Yeah, these three terms are in common difference. The common difference is there. This plus this divided by 2 is equal to a. Correct? So no problem. But when I'm doing this, I'm directly getting 3a is equal to 15 because minus d and plus d is getting cancelled, and I can directly say that a is nothing but equal to 5. That means first the middle digit is 5. That means I can say the middle digit is 5. Correct, no? Sir, this actually solved my problem a lot. Now what am I going to do? I'm going to use the second information. The number obtained by reversing the digits is 594 less than the original number. By 15 is 10 less than 25. So 15 is equal to 25 minus 10. Right? Number obtained by reversing the digits. That means 100 multiplied with a plus d plus 10 multiplied with a plus a minus d. This is the reversed number, which is 594 less than the original number. Original number would be 100 into a minus d plus 10 into a plus a plus d minus 594. Okay ji, 10a directly gone. Okay ji, this a directly gone. Okay ji, 100a directly gone. Okay. What do you get? From this side you are going to get 100d minus d is equal to minus 100d this side, right? Minus 100d. What is left? Plus a also gone, no? Achha, a I didn't plus d. A was gone, minus d will remain here, plus d minus 594. A to I already have, na? A I already have. A got cancelled also, but A I already have. See, D is also getting cancelled. Everything is getting cancelled. So what will be D? 99D is equal to minus 99D minus 590. Are we doing correct? Or is something wrong? Tell me, value of D. Value of D. Minus 3. Are we getting? Yes. D is equal to minus 3. Awesome. D is minus 3 and A was equal to 5 already. That means my digits, what is the number? These digits. These are nothing but 5 minus minus 3. That means 8. Then second digit is A, that means 5. A plus D, that means 5 plus minus 3. 5 plus minus 3 would be 2. So original number is nothing but 852. And reverse number is nothing but 258. And you can see 852 is exactly 594 less than the 852. 258 is 594 less than 852. What if D is greater than A? So A minus D would be negative. Yeah. No, that won't come only, na beta. That situation won't happen only. Right? That cannot happen. The question will be framed in such a way. They'll also check the data while making the question. Na? It won't happen only. Impossible. That won't happen. Okay, they'll not give you a situation like that in which this thing is happening. Okay, that means question is incorrect. That means that the information given in the question is incorrect. Okay ji, understood? So original number is 852, reverse number is 258. Okay. All right. Now suppose if you have to choose 4 numbers, then choose it like this: a minus 3d, a minus d, a plus d, a plus 3d. Why did we not do a plus 2d, sir? If we do, suppose if we did like this: a minus 2d, a minus d, a plus d, and a plus 2d. What is the common difference in these two? D. Okay, no problem. What is the common difference in these two? The common difference in these two will be 2d. The difference over here is d. Here the difference is becoming 2d. Not same. You can clear, definitely. Not same. So that's why we choose 3d. So that difference over here is 2d. Here also difference is 2d. Here also difference is 2d. And here also everything minus 3d plus 3d is getting cancelled. minus d plus d are getting cancelled. 5 terms, choose like this: a minus 2d, a minus d, a plus d, a plus 2d. Okay, 3, make it 5. For 4, start with a minus d, a plus d. Whatever is the difference, create it on the both sides. Okay, all right. Let's go ahead. This thing I told you, nth term of nth odd number, any odd number, nth odd number you can write it as 2n minus 1. And the sum of first n odd numbers, 1 plus 3 plus 5 plus 7 plus 9 plus 11. How many odd numbers? 6 odd numbers. This will be equal to 6 square. Okay, 1, 3, 5, 7. How many odd numbers? 4 odd numbers. Sum will be equal to 4 square. First 4 odd numbers is equal to 4 square. First, and how is this coming? Sum of n terms, sum of n odd numbers. So n by 2 multiplied with first odd number 2 into 1 plus n minus 1 into common difference. What is the common difference between odd numbers? 2. When we are solving this, this is coming out to be as n square, nothing else. Okay, this is coming out to be as n square. This will be equal to n square. This is how we are getting. So sum of first n odd numbers will be equal to n square, and sum of first nth odd number, any odd number, general term for odd numbers, general term for odd numbers, right? General term for odd numbers will be 2n minus 1. Okay, chaliye, let's go ahead. Now let's come on to another type of progression. Okay, another type of progression which is called geometric progression. This time there is no common difference, there is common ratio, something like this: 2, something like this: 2, 4, 8, 16, 32, 64, 128. It is progressing like this. Let's study this now, right? Common ratio: 4 by 2 is 2, 8 by 4 is 2, 16 by 8 is 2, 32 by 16 is 2, this is 2, this is 2. Common ratio is there. Okay, common ratio is there. Very good, amazing. So common ratio, how will we write it? First of all, how will we write a GP? First term, let's say is A. This is your first term, and let's say your common ratio is R. This is your common ratio. Okay, something which is getting multiplied in every subsequent term. So how will you write it? How will you write a GP? Your GP will look like this: A will be the first term, second term will be A multiplied with R, third term should be A multiplied with R multiplied with R, fourth term should be A multiplied with R multiplied with R multiplied with R, that means AR cube, then AR to the power 4, right? So first term is A, second term is AR, third term is AR square, fourth term is AR cube, fifth term is AR to the power 4, right? What will be 10th term? AR to the power 9. What will be nth term? AR to the power n minus 1. Correct? Tn divided by Tn, Tn divided by Tn minus 1 is equal to R. Very good, Aditya. Correct? AR to the power n minus 1. This will be your nth term. So general term Tn comes out to be as AR to the power n minus 1. This is your general term, any term. Suppose for this GP, you need to write the 10th term. So 10th term will be nothing but 2 into 2 to the power 9. This will be your 10th term. That means 1024 will be your 10th term. Obviously, right? 2 to the power 10. Okay, 1024 will be your 10th term. Now, about this is your general term of an AP. We can also understand one thing, that any term divided by its preceding term is equal to R. Just like in AP, we had Tn minus Tn minus 1, which was equal to D. Just like this, right? This was for AP and this is for your GP. Any term divided by its previous term will give you the common ratio. Okay. So now this is general term. General term we realize is nothing but AR to the power n minus 1. Okay. Now what about sum of terms? Second question comes is, what about the sum of terms? So sum of n terms, we'll try to realize how we'll find that. A plus AR plus AR square plus AR cube till AR to the power n minus 1. Till here, AR to the power n minus 1. Now, in just like in GP, no, just like in, sir, please find a method to find the sum of HP. Nobody could find, bacha. Nobody could find. Sum of harmonic progressions is not there. Okay, it's not defined, and there is a reason why it is not there that I can explain when we go to HP. Okay, ji. Okay, this is sum of n terms of a GP. All right. HP is harmonic progression. Don't worry, don't worry. Stay with me. Stay with me. We'll learn step by step. Okay, now one more thing, no? Here. When I'm writing this, no, 2, 4, 8, 16, 32, 64, 128. Okay, whenever I'm writing this, no, what I see is the product of these two. What is it? 256. Product of these two, 256. Product of these two, 256. Square of 16, 256. Just like in arithmetic progression, where the sum of the equidistant terms was fixed, common, okay, constant, or same, equidistant terms. Equidistant term. This is a small part of a GP. GP can be very big. But when we write this part, in this part, equidistant terms product will be fixed. Right? Whatever is 2 into 128 is 4 into 64 is 8 into 32 and is 16 square. So by this I realize that, yaar, why don't we just just multiply the common ratio? Why don't we just multiply the common ratio in every term? What will happen? Let's see. Right? Common ratio, if we multiply, and one more thing, that if I'm multiplying the equidistant terms, suppose by the same idea, if I do this, Sn is equal to, just like I did in AP, right? I'll write it reverse. AR to the power n minus 1 plus AR to the power n minus 2, like this, somewhere over here AR, and then final term is A. Is the ratio fixed? A square, R square to the power n minus 1, it is coming. Nothing is happening. But how will I subtract? What will I do? How will I find the sum of n terms? By if I'm writing the same thing in reverse order and then I'm multiplying, here also I'm getting AR square to the A square R to the power n minus 1. Here also I'm getting A square R to the power n minus 1. By 1 plus n minus 2 will be n minus 1 only. Product is coming, okay, no problem. But if I multiply, when I'm going to multiply these two, I'll get Sn square. Ayyo, Rama, I don't want that. Sn square of sum of n terms, then right side will be square root. Oh, no. What I'm going to do is I'll multiply this series. I'll multiply this series with R, both sides. So here I'm going to get AR plus AR square plus AR cube plus AR to the power 4. Okay, till AR to the power n minus 2. Right? What will this term become? This term, when I multiply with R, I'll get AR to the power n, right? And second last term will be AR to the power n minus 1. Because before this it will be n minus 2 multiplied with R, n minus 2 plus 1 will be n minus 1. Okay. Now what? If I subtract, you see, if I subtract, what is happening? Now if I write in reverse order, what do you see? Is there a difference if I write it in reverse order now? Huh? If I write it in reverse order now, R into sum of n terms, AR, right? Okay, first equation, and look at this equation, right? I'm writing the same thing in reverse order. Okay, I'm writing the same thing in reverse order, multiplying with n. Last term multiplied with R, it will become AR to the power n. Plus second last term, what will be the second last term? AR to the power n minus 2 multiplied with R will become AR to the power n minus 1, correct? Correct. So here I'll get AR to the power n minus 1. Here what will I get? AR to the power n minus 2. Okay, like this AR to the power n minus 3, and last term will come as AR. I just shifted the series a little bit. Now subtract. Now these two. Now what I'm going to do is subtract. So Sn will come out as common. What will I have? 1 minus R. A minus AR to the power n and AR minus AR to the power n minus 1. Right? If I do, getting my point? What am I getting? Same difference I'm getting. No, I'm getting this only. A minus AR to the power n. I'm getting this only. Right? Because terms are going to get cancelled. No, this term is getting cancelled. Second term, second last term is getting cancelled. This term is getting cancelled by this. All terms are getting cancelled. Can you see this? So I have a formula. Sum of n terms into 1 minus r is nothing but a into 1 minus r to the power n, and this will become a into 1 minus r to the power n divided by 1 minus r. This is my sum of n terms of a GP, geometric progression. Terms are getting cancelled over here, right? When you subtract this series with this series, AR minus AR will become 0. AR square will get cancelled with the second last term. Only terms which are going to remain is A minus AR to the power n. That's it. Only this is going to remain. Everything will get cancelled. Everything. All these terms will get cancelled. Only A and AR to the power n are going to remain. That is why I have a formula. Sum of n terms is nothing but A into 1 minus R to the power n divided by 1 minus R. Do we understand this? Come on, tell me. Are we clear? Yes, good. So for you the formulas. Okay, this formula I'll come to. The two formulas you have. Okay, any common term, any general term of a GP is AR to the power n minus 1, and sum of n terms of a GP is A into 1 minus R to the power n upon 1 minus R. All right. Sir, summary once. Summary. Okay, this is the summary. Formulas. Okay, derivation you can see again. Right? Try to do it by yourself. Gave you the idea. How the idea came, everything I explained. Right? This is the summary. Sum of infinite terms I'll explain. How is it like that? But the two formulas you should note. Right? Now in AP, suppose there are three terms A plus D, A plus 2D. Right? Three terms. The sum of these two terms, that means A plus 2D divided by 2 is always the middle term, right? If there are three terms in AP, the sum of A plus C divided by 2 will be equal to B. Okay, A plus C, this is called arithmetic mean, equal to B, right? GP, if there are three terms in GP, then what will happen? The square of the middle one will be equal to the product of the two. Third thing we need to remember is that there cannot be any term in GP which is 0. Obviously, if there is any term of GP which is 0, whatever we multiplied that 0 with, every term should be 0, right? So there cannot be any term in GP. Geometric progression is progression of your products. So there cannot be any term which is going to be 0, obviously. But obvious this is, right? But don't forget to like and like and comment. You guys are not doing that. I saw the last one. I was like, yeah, what's okay? This is going to help you a lot with a lot of patterns, whatever we are doing, no? All right, B square is equal to AC. These two are the properties. General thing, right? This is called geometric mean. This is called arithmetic mean. We'll come to that. But for now, understand this. Note this down. Now, for the sake of general questions like these, if first term of GP is equal to minus 3 and the second term is equal to the fourth term, find the seventh term. Have I written correct? First term is minus 3. Second term will be AR. Fourth term will be AR cube. Geometric mean this thing only, bacha. this thing only. Geometric mean means, suppose if there are three numbers, if there are two numbers 3 and 4, their geometric mean will be square root of 12, right? Geometric mean 3 into 4 square root, right? So GM will be equal to square root of 3 into 4. GM was what? B. So B square was equal to A into C, no? So B square will be equal to 12, then B will be equal to square root 12. And this square root 12 only is geometric mean. Okay, right? Here, what to do? Baba, R cube, R square is equal to 1. This is what we are getting from here. A cancelled, R square is equal to 1. So R will be equal to plus or minus 1. Either R can be plus 1 or it can be minus 1. So seventh term, T7 will be equal to what? AR to the power 6. That means minus 3 into 1 to the power 6 or minus 3 into minus 1 to the power 6. Both are going to be same because power is 6. Okay, so minus 3, right? Minus 3. Actually, all the terms of this geometric progression will be minus 3, 3, minus 3, 3, minus 3, 3. Either this will be your geometric progression. If the ratio is 1, then minus 3, minus 3, minus 3, minus 3. All the terms are these. All the terms are minus 3. There is no problem. 0 cannot be a term. Constant GP, no problem. Sign changing GP, no problem. 0 cannot be a term. Okay, 0 cannot be a term. Something we did. Second term is equal to fourth term, correct? So R square is equal to 1. Correct only, no? Answer galat. Huh? Acha, square and the second term is equal to, correct only we did, correct only we did, correct only we did. Suppose x, 2x plus 2 and 3x plus 3 are the first three terms of GP, then find the fourth term, right? These are the three terms of GP. Then we have to find the fourth term. No problem. We know one thing, that 2x whole square, middle term whole square. Geometric mean, no? 2x plus 2 whole square will be equal to x multiplied with 3x plus 3. This is it. This is what's going to be. We'll solve this. Let's see. 4x square plus 4 plus 8x is equal to 3x square plus 3x. Okay. So x square plus 5x plus 4 is equal to 0. Right? So x minus 4 into x minus 1 is equal to 0. X can be equal to 4 or x can be equal to 1. Now, we'll check if x is equal to 1. If x is equal to 1, terms are, what will be the terms? Terms will be 1. Wait, 1 minute, minus 4 minus 1. Oh, no, something wrong. No, 4 plus 1. X plus 4, x plus 1. X plus 1 is equal to 0. So, x can be equal to minus 4 or x can be equal to minus 1. Okay. So, if x is minus 1, terms will be what? Terms will be 1, 2 into 1 plus, minus 1. Minus 1 will be the first term. Second term will be minus 2 plus 2. That means 0. Third term will be minus 3 plus 3. That means 0. So, wrong. 0 cannot be a term of GP. If x is equal to minus 4, first term will be minus 4. Third term will be minus 8 plus 2. That means minus 6. Second term. Third term will be minus 12 plus 3. That means minus 9. And this is a GP. You can see minus 6 by minus 4 is 3 by 2. Minus 9 by minus 6 is also 3 by 2. So 9 into 3 by 2 you can directly do to find the fourth term. Okay. 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 Minus 9 into 3 by 2. Minus 27 by 2 will be your fourth term. Direct solving. जल्दी में करने में यही होता है. ठीक है. ओके. अभी स्लो. अभी ऑल राइट. कोई नहीं. All right, understood? So this is how you can check. Chalo, let's try this one. In a GP, in a GP, let me remove this. In a GP, we have A1 plus A2 plus A3. That means first term plus second term plus third term. अच्छा वो अपने आप को बोल रहा है A1 square plus A2 square plus A3 square is 91. Find R. चलो, try this for a minute. I'll just have some water and come back. Okay, try this. Done? Any progress? A by R, A R. नहीं होगा उससे कुछ. Simply let's see, no, A plus AR plus AR square. Okay, this too we know is equal to 13. Okay, what do we have here? A1 square, that means A square plus A square R square plus A square R to the power 4 is equal to kitna? 91. This is what is given to me. All right. So what I can do is I can take A common from here. 1 plus R square is equal to 13, and from here A square common, then 1 plus R square plus R to the power 4 is equal to 91. Still no benefit. Let's do one thing. If I want to cancel A square, my brain says, my mind is saying, if you want to cancel A square, we can get rid of directly A square, no? We can directly get rid of this A square. If we write like this, A square multiplied with 1 plus R square whole square is equal to 169. Any problem? I squared both the sides. So I can cancel A square. Right? Now these two I'll divide. So I'll get 1 plus R square plus R to the power 4 whole square. Oh, sorry. R square. 1 plus R square. Sorry. This will remain 1 plus R square. 1 plus R. Arey yaar. What am I doing? Okay. All right. Okay. So I'm going to go get, if I divide these two, na, what am I going to get? 1 plus R square plus R to the power 4 divided by 1 plus R square to the whole square. This is equal to 91 by 169. Not even cancelling. Not even cancelling. 7. No, 7 also not. Not cancelling. All right. We'll do something. You got what I am trying to say. Actually, what you need to know over here is that x to the power 4 plus x square plus 1. Whenever you see this expression, no, you can actually write it like this: x to the power 4 plus 2x square plus 1 minus x square. Can I write it like this? I just added x square and subtracted x square, plus x square minus x square. So that plus x square I added with x square, so it became 2x square, and minus x square I wrote over here. Why did I do this? Because this particular thing I can write as x square plus 1 whole square, and this minus x square. And after this I know what to do. This is a square minus b square, so x square plus 1 minus x into x square plus 1 plus x. A plus b into a minus b. Okay? A plus b into a minus b. I can write like this. Any problem? No problem. What benefit am I getting? What benefit am I getting? The upper expression I'm going to write as 1 plus r square multiplied with 1 plus 1 minus r plus r square divided by 1 plus r square whole square. This is equal to 91 by 169. I cancel this with this. That's why I did this. Oy, ulta, galat, galat, galat. This with this. Okay. So I have 1. What do I have now? I have 1 minus r plus r square divided by 1 plus r square is equal to 91 by 169. This is what I need to solve. That's it. Almost don't want to write the answer. Okay. This is what you need to solve. And this we can solve. Na? This we can solve. 169 r square plus, minus 169 r plus 169 is equal to 91 plus 91 r plus 91 r square. Okay. So this will become 78 r square and solve for r. Can you solve for r quickly, please? Can't d, can d. Solve for r square over here. Mm, 78. This is out. It's going to be. Use componendo and dividendo. Componendo, dividendo. Very good idea. That also can be used. 1 minus r plus r square plus 1 plus r minus 9. Not much of benefit we are getting here from componendo dividendo also. You'll have to solve for r. It's better. Okay, it's better we solve for r. By 13, you can divide it by 13. Na? 13 into how much is 78 is 6. 1 3 are 3, 3 3. Sorry, 1 6 are 78. 13, 6 r square minus 20 r plus 6 is equal to 0. है ना? तो 6 r square minus 18 r minus 2 r plus 6 is equal to 0. Sum is minus 20, product is equal to 36. So 6 r into r minus 18 minus 2 I understand. R is equal to 3. Either it is 2 by 6 or 3, 1 by 3 or 3, right? R is 1 by 3 or 3. R is equal to 1 by 3 or R can be equal to 3. There will be two possible values of R. Okay? And once you have R, you'll have two values of A also. You'll have two values of A also. Let's check. Must have the answer. R is 3 or 1 by 3 and there'll be definitely two values of A also. Achha, find R. We had to find R only. That's why. Now, let's talk about what if there is an infinite GP and in what case can we talk about infinite GP, right? So, there is some concept called sum of infinite terms of GP, S infinite of GP. Okay, when can this happen? Let's see. Sum of n terms, we write it as A into 1. Sum of n terms we write no A into 1 minus r to the power n divided by 1 minus r. This is how we write sum of n terms. Infinite GP means AR square, AR cube. It's going on, infinite terms are there. We don't know how many terms are there. We don't know. Infinite terms are there. Too many terms are there. Whenever in this formula, if your R is between -1 to 1, between, not 1 and -1. If it is 1, if R is 1, then it's a constant GP, no. If R is -1, then it's a sign changing GP. So in that case, we can find the sum. For a sign changing infinite GP, sum will be 0. For if R is 1, then sum will be infinite. Obviously, sum will be infinite. Only if your R is between -1 and 1. That means R is small. Or we can write it as mod of R. Correct. Mod of R is less than 1. Mod of R is less than 1 means R is between -1 and 1. Okay. This same thing. This is the same thing. In that case, what happens is, this R to the power n becomes R to the power infinity. And because your R is between 1 and -1, it will be 1 divided by something. 1 divided by something. Between 1 and -1, 1 divided by something. This 1 divided by something to the power infinity will become 0. 1 divided by a very large number is approximately equal to 0. That means this term is going to become equal to 0. That means your sum of infinity will be nothing but a into 1 minus 0 divided by a minus r. That means a by 1 minus r for GP. I hope you understand this. Correct? A is equal to a, sum of infinite terms will be nothing but a divided by 1 minus r. Very beautiful. Nice. Okay, sum of infinite terms also we are able to write over here. Now, let's go back to this question. Sum of infinite terms of a GP is 20. Sum of infinite terms of a GP is 20. Okay. And the sum of their squares is 100. Oh. Then find the common ratio of GP. Try doing this. Formula of infinite terms is a by 1 minus r. Very easy. By which thing? This thing? This thing? I am saying that if your common ratio is between -1 and 1, not -1, not 1, just between them, it will be 1 divided by something. All the numbers between -1 and 1 are -1 divided by something or 1 divided by something. Now 1 divided by something. What is the term over here? This r to the power n thing means r to the power infinity. N means sum of infinite terms means n is infinity. Right? So r to the power infinity. Now if your r is 1 divided by something, this to the power infinity will be 1 divided by something to the power infinity. That means 1 divided by something very big, which will approximately be equal to 0. It should be approximate, tending to 0. Okay. Now understood? Now understood? Sum of infinite terms will be equal to 0. Okay. Now based on this, try solving this question. Sum of infinite terms of a GP is equal to 20 and sum of their squares is equal to 100. But if there is a GP AR cube, AR to the power 4, square of terms will be A square R square, A square R to the power 6, A square R to the power 8. Correct? What is the ratio over here? R square. Wait. Sum of their squares. Come on, tell me. This will be R. Okay, ratio will become R square, no? Right? The ratio of this is R. The ratio of this is R square. Okay. Any problem? Any problem? No problem, sir. Right? Sum of infinite terms of a GP is 20. Sum of infinite terms for the squared GP. Squared GP will be equal to what? First term of the squared GP will be A square. Okay. This is given to you as 100. Okay. This formula we know, a divided by 1 minus r. This formula is what? First term will be a square, common ratio will be r square, nothing else. Okay, solve this. Same technique you can use. By divided by 1 minus r is equal to 20. So a square divided by 1 minus r whole square will be equal to 400. Right? A square divided by 1 minus r whole square will be equal to 400, correct? And already a square divided by 1 minus r square, this is given to me equal to 100. This is my first equation. This is my second equation. I'll divide both of them. And what am I going to get? A square. I wanted to get rid of a square, that's it. So 1 minus r square divided by 1 minus r whole square is nothing but 400 by 100, that means 4. So just solve this, because this will be 1 plus r divided by 1 minus r equal to 4. One plus r will be equal to 4 minus 4r. All right. R is equal to 3 by 5. Simply. Somebody just gave also, I think 3 by 5. 3 by 5. Very good, Aditya Sharma. R will be equal to 3 by 5. Correct? So R is smaller than 1. You can see it is between minus 1 and 1. By factorize this, no? 1 minus r into 1 plus r. 1 minus r will cancel with 1 minus r. And 1 plus r upon 1 minus r will remain equal to 4. R is equal to 3 by 5 we are getting. Okay, and we can see also r is between 1 and minus 1. That is why sum of infinity is possible. Otherwise, sum of infinity is not possible. Correct? Okay, ji, okay, ji, okay, ji. Okay, try this. Sum of n terms. You have to find the sum of n terms of, you have to try and find the formula or expression for sum of n terms of this particular sequence. Come on, try it. Take a minute, try. Look, come on, let's see. But directly we are not seeing anything. Obviously, we are not seeing anything directly. So nothing. Here also there is a square. Okay. Here also there should be a square. A square of terms. Okay. So this is something like this. Then x to the power 4 plus 1 by x to the power 4 whole square will come. Okay. Terms are there. Terms are there. We have to find the sum of n terms formula. First of all, sum of n terms will be what? Let's write it. If I open this, if I open this, x square plus 1 by x square plus 2 into x into 1 by x, that means plus 2. Okay. If I open this, it will be x to the power 4 plus 1 by x to the power 4 plus 2 into x square plus 1 by x square. So plus 2. Wow. X to the power 6 plus 1 by x to the power 6 plus 2. Similarly, x to the power 8 plus 1 by x to the power 8 plus 2. Correct? I'm just opening these. I'm just squaring. Okay. I'm just squaring k square minus 2 k square minus 2. Okay, I'm just squaring. And as soon as I did this, I realized, yeah, this is nothing. I can write it like this: x square plus x to the power 4 plus x to the power 6 plus x to the power 8. Okay. This is going to be one thing. And these 1 by x square. So 1 by x square plus 1 by x to the power 4 plus 1 by x to the power 6 plus 1 by x to the power 8. This is one thing. Plus 2 into 2 plus 2 plus 2 plus 2 plus 2 n times. This is one thing. Three things I can separate this into. Can you see this now? Now you must have realized, yeah, this could be done. Right? These are all n terms. We have to find sum of n terms. Right? So these are n terms. Here also n terms. Here also n terms. here also n terms. Okay. Sum of n terms of this. What is the common ratio? R is nothing but x square. What is A? A is nothing but x. This is GP, right? This is GP, x square, x to the power 4, x to the power 6, x to the power 8. This is GP. This is also GP. A is what? 1 by x square. R is what? 1 by x to the power 4 divided by 1 by x square. This will be 1 by x square. R is also 1 by x square. Okay, ji? Correct, no? Correct, no? Sorry, 1 by x square. A and R both are 1 by x square. Here, this is directly you can write. Here, sum of n terms will be 2 into n. 2 is getting added n times, so 2 into n. What will this be? Sum of n terms. This will be n terms, sum of n terms. A into 1 minus r to the power n, that means x square into 1 minus x square to the power n divided by 1 minus r, that means 1 minus x square, plus here a, that means 1 by x square into 1 minus r to the power n, that means 1 by x to the power 2n divided by 1 minus 1 by x square. Wow. Right? Plus 2 into n. This will be the entire formula. This is going to be your formula. When you solve this, your final answer should come like this. Right? Final answer should, our answer is also quite, just taking some things common, final answer will come out like this. My mind lagged while solving. No, you can solve it here. You have to solve, you have to now start realizing, acha, this is AP, this is GP, here I can use sum of n terms. Now you will be capable of solving a lot many types of series. Okay, there will be a lot many types of series which you will be able to solve. Okay, for example, one more I'm showing you just now. After that, we'll go on some more concepts. Okay, for example, something like this. Okay, something like this. Now we'll be able to crack a lot of types of series by breaking them into APs and GPs, different types of series, or just writing the general term. There are more methods we'll learn, but for now, this. Okay, for example, let's look at, I'm just giving you an example. Don't panic if you don't understand. I'll explain it again. Don't worry. I'll come at more things, but I'm just showing you that how are we going to use the concepts that we learned so far and use them to solve the questions of IOQM. These are some of these questions, some of these series and addition and subtractions are from PYQs of IOQM only. For example, let's see this. What is this? 2 by 100. Oh, sorry, 2 by 10 plus 4 by 100 plus 6 by 1000. Okay, plus 6 by 1000, and it will keep going on like this. Now, this is this AP? Check, is this AP or GP, something like that? What is this? Is this AP? Ha. Ye AGP. This is AGP. This is what we are going to call AGP. And about AGP also, there is nothing to panic. Okay, what is an AGP? AGP looks like this. Okay. Question, Mayank Sharon, bolo. Tell me. Okay. The series just now we saw is neither an AP nor a GP. Instead, it's a mixture of both AP and GP. It's a combination. And we can solve these type of things also without any problem. Without any problem, we can solve something like this also. Okay. Obviously, it will be a bit complex, but with practice, we'll be very gelled up with it. We'll be very comfortable with it. Now, suppose we have to find by nth term. Nth term, so we can write no first term r is equal to 0. second term r is equal to 1, third term r is equal to 2. I mean, like, first term r to the power 0, second term r to the power 1, third term r to the power 3, fourth term r to the power fifth term r to the power 4, and nth term will have r to the power n minus 1, right? R to the power n minus 1, a plus n minus 1 d. Now, okay, now let's see how will we deal with it. Suppose sum of n terms have a plus a plus d into r, right, plus a plus 2d into r square, okay, plus a plus 3d into r cube. Let's do it with a question only, no, this question. Okay, this is the question. Now this is AP and GP both. 2, 4, 6, 8, 10 is making a GP, is making an AP, and 10, 100, 1000, this is making a GP. 1 by 10, 1 by 100, 1 by 1000 is making a GP. How do we solve it? Sum of infinite terms we need to find, for example. Okay, the first step to solve a sequence which is a combination of AP and GP both. Here first A is what? A is equal to 2, R is equal to 1 by 10, and D is equal to 2 again. Correct? Any term of this AP, any term of this sequence can be written like this: A plus n minus 1 D multiplied with R to the power n minus 1. Suppose I want to write the third term. This will be the general term. Third term I want to write. Third term will be 2 plus 3 minus 1, that means 2D, multiplied with R to the power 3 minus 1, that means 2. This is what? This is 2 into 1 plus D. Acha, D is also there, no? D is 2. 4 plus 2, 6 into R square. That means 6 into R is 1 by 10. 1 by 100. But, okay, getting my point. But here actually what the problem is, there is a problem. Let's solve a little bit easier version of it. For example, let's say we have something like this. Okay, something like this. Suppose Sn we need to find. So 1 plus 3x plus 5x square plus 7x cube. This is neither an AP nor a GP. Instead, it's a mixture of AP and GP both. Sir, एक और doubt है, find the sum of n terms and also S infinity 3 by 5. ठीक है. AGP questions. Okay, right? 1 plus 3x plus 5x square plus 7x cube. This is kind of an AGP. You can see. What do we do is, the method is multiply with R. What is R over here? What is R over here? R is x. So multiply with x. So x into Sn will become x plus 3x square. Every term will get multiplied with x. 1 into x is x. 3x into x is 3x square. 5x into x is 5x square into x is 5x cube. 7x cube into x is 7x to the power 4. Right? To n terms, and this is also till n terms. What will be the nth term if I want to write the nth term? If I want to write the nth term, what will it be? By second term has x to the power 1, third term has x to the power 2. 1, 3, 5, 7, odd numbers. Odd numbers are starting from 1 to 3n minus 1. How can I write? 2n minus 1, right? 1, 3, 5, 7. 1, 3, 5, 7. The general term will be 2n minus 1. Do you understand directly now? General term. N is equal to 1 will give you 1. 2 into 1 minus 1 is 1. N is equal to 2. That means 4 minus 1. That means 3. So this will be general term. 2n minus 1 into x to the power n minus 1. Correct? What will be the first term, for example? 2 into 1 minus 1, that means 1 into x to the power 0. That means 1 only. Second term will be 4 minus 1, 3 into x to the power 2 minus 1. That means x. That means 3x will come. Okay. This is how we are going to deal with it. Right? 2n minus 1 into x to the power n minus 1. Why did I multiply with x? Why did I multiply with the common ratio? When I am multiplying every term, this will become the second last term. Right? If I am multiplying x in every term, the last term will be 2n minus 1 into x to the power n minus 1 multiplied with x. right? Every term is getting multiplied with x. So multiplied with x will become minus 1 plus 1. That means x to the power n will become the last term. And second last term will be 2n minus 1 into x to the power n minus 1. Got my point or not? Why did we do so? When we subtract these two, we get Sn minus x into Sn. Sum of n terms minus x into sum of n terms is equal to what? I got 1 as it is, no problem, plus 3x minus x plus 5x square minus 3x square plus 7x cube minus 5x cube. Like this it is going. Okay. And what am I going to get over here? 1 I left. No, I just shifted it. This series just got shifted, nothing else. This just got shifted. Getting my point? How are we getting it? Right? This just got shifted, nothing else. So we are going to get 1 plus 2x plus 2x square plus 2x cube. Like this is going to go. What about the last term? Think about it. What about the last term? What about the last term? Think about it. Right? This term will get subtracted with what? This term. This will be not 2n minus 1, this will be 2n minus 1. No, second last term, this term. Okay. Second last term will be here also n minus 1 we'll have to put. No, so 2 into n minus 1 minus 1. So 2 into n minus 1 minus 1 will be into x to the power n minus 1 will be the second last term. So this is 2n minus 2 minus 1. That means 2n minus 3. And this is 2n minus 3. So you'll be able to see more clearly. Second last term will be 2n minus 3 into x to the power n minus 1. Now subtract these two. Again we are getting what? 2 minus 1 minus minus 3 will be 2. So 2 into x to the power n minus 1 will be the second last term. And this, because we are subtracting this from this. So here we'll get a minus. And minus may we'll have 2n minus 1 into x to the power n. Getting my point? Now this entire thing, it's a beautiful thing. We know what to do with it. 2 if we take common, it's nothing but x plus x square plus x cube till x to the power n minus 1. That means how many terms do we have over here? N minus 1 terms we have over here. Minus 2n minus 1 into x to the power n. Okay, 2 we took common. Now we can solve it. There is no problem. We can write it as 1 plus 2 into a is x into 1 minus r to the power n. R is what? X. 1 minus x to the power. How many terms are there? N minus 1 terms are there. Right? Divided by 1 minus x. Okay. Minus 2n minus 1 into x to the power n. This will be the, this is what? This is your x, this is 1 minus x multiplied with Sn. And now this 1 minus x we can shift over here. It looks very difficult. It looks very, difficult right now because we are finding the sum of n terms. So this 1 minus x will get divided everywhere over here. Okay, this 1 minus x will get divided. Finally, what we are going to get is Sn is 1 divided by 1 minus x plus 2 into this thing, 2 into x into 1 minus x to the power n minus 1, 2x into 1 minus x to the power n minus 1, and denominator mein we had 1 minus x, again 1 minus x came from here, so it will get squared, plus 2n minus 1 into x to the power n divided by 1 minus x. This will be your sum of n terms for that particular expression. Okay, but when we are solving, when we'll be solving something like this, This is not going to make it that complicated. Let's see how. Let's see how. So we know that it is an AGP. We just need to know the first step. We just need to know the first step, that what is the first step. So first step is multiply with common ratio. Multiply with R. First step is always multiply with R. First step will be this only. First is multiply with R. Once you have multiplied with R, this S infinity will become what? Same thing, same thing. 2 by 10. R is what? R is equal to 1 by 10. And R is equal to 1 by 10. R. Don't look at AP, only R. Don't, AP is different and GP is different. There is a GP also 1 by 10, 1 by 100, 1 by 1000. AP is also there 2 plus 4 plus 6. Okay. What you do is multiply with R. Let's take it on another. Okay, let's do it over here. Okay, when you multiply with R, you will get 2 by 10, 2 by 100, right? Plus 4 by 1000, plus 6 by 10,000. Okay, and it will keep going on like this. Okay, this is 1 by 10 multiplied with S infinity. Same thing we multiplied with 1 by 10. Same thing. S10, S infinity multiplied with 1 by 10. Every term got multiplied with 1 by 10. What benefit we got? When we are doing these two, when we are subtracting these two, what are we getting? S infinity into 1 minus 1 by 10 is equal to 2 by 10 as it is, no problem. But here we got 4 by 100 minus 2 by 100 plus 6 by 100, sorry, 6 by 1000 minus 4 by 1000. And this is how it is going to propagate without any trouble. Okay, so what do I have? S infinity into 1 minus 1 by 10, which is again 9 by 10, is equal to 2 by 10 plus, here there is a thing, this thing I wrote, no, 4 by 100 minus 2 by 100 plus 6 by 100, 6 by 1000 minus 4 by 1000. Okay, and it is going to keep going on like this for infinite terms, right? Now S infinity into 9 by 10 is equal to what? 2 by 10 plus, from here everywhere 2 will come out to be common. What will remain? 1 by 100. 4 by 100 minus 2 by 100 is 2 by 100. This is also 2 by 1000, then 2 by 10,000, then 2 by 100,000, like that it will keep going on. 1 by 100 plus 1 by 1000, I mean same thing, this thing, 1 by 10 square plus 1 by 10 cube plus 1 by 10 to the power 4 till infinity, it is going to go like this, right? So sum of infinite terms into 9 by 10 is nothing but 2 by 10 plus 2 into sum of infinite GP. This is what? Infinite GP. This is what? Infinite GP. Nothing else, right? This is infinite GP. And we know one thing about infinite GP. Sum of infinity for infinite GP will be A upon 1 minus R. That means what is A? 1 by 100 is A. Divided by 1 minus what is R? In this GP, R is 1 by 10. 1 by 10 cube minus 1 divided by 1 by 10 square will be 1 by 10. So 1 minus 1 by 10. This is what we are going to have. Okay. So this is going to become 9 by 10, 1 by 100 upon 1 by 100 into 10 by 9, 1 by 90. This is just come as 1 by 90. Sorted. You have the formula, right? How easy is this? No, it's not time taking. It's just that you need to follow the formula. Now, in some books, they can give you a direct formula also. In some books, no, there is a formula for infinite terms of AGP, right? And this formula is like this. Okay, this formula is nothing but A upon 1 minus R plus dr upon 1 minus R whole square. This is the formula. Okay, this is the formula. How is this coming? I'll show you how is this coming, right? When we have this, no, A plus D into R plus A plus D into R square, right? These infinite terms, right? Infinite terms of an AGP. This is AGP. Okay, this is AGP. When I multiply with R, what do I get? AR plus A plus D into R square. plus a plus d into r cube, and it is going to keep going on like this. Now subtract these two. So 1 minus r into sum of infinite terms is equal to what? This minus this, a plus d into r minus ar will be dr. A plus d into r square minus a plus d into r square will be equal to, sorry, a plus d into r square plus a, ये 2d है भाई, this is 2d, a plus d, okay, a plus 2d into r square minus a plus d into r square will be equal to what? A plus 2d into r square minus a plus d into r square will be equal to what? Dr square. Like this, next term will be dr cube, and it is going to keep going on like this. So what do we have? 1 minus r into sum of infinite terms is equal to a plus d common, r plus r square plus r cube till infinity. And here also it is necessary that r should be between -1 and 1. Here also mod of r is less than 1. Okay. So this thing becomes what? This thing is what? This is a upon 1 minus r, where a is r itself and a is r itself, right? This is a upon 1 minus r, a is r, first term is r itself. So r upon 1 minus r multiplied with d plus a. Right? When we solve this, we get sum of infinite terms is equal to a upon 1 minus r plus dr upon 1 minus r whole square. This 1 minus r came over. This is how this formula comes. But it's better that we know the approach instead of the formula. It's better that we know the approach instead of knowing this formula and mugging this up. Why not to mug this formula? Because this formula will not work when the first term is multiplied with r. Just like this question. In this question, this formula will not work. In this question. Why? Because first term is multiplied with 1 by 10. First term is not alone. A is not alone. When we derived the formula, A was alone. But here A is not alone. Okay, get my point? A should be alone. Here A, if only 2 was there and the series, rest of the series was starting from here, then that formula could work, but here it won't work. Here you'll have to solve it just like this. Okay, the formula won't work. So it's better that we don't remember the direct formula. Our answers might come wrong. Okay, ji. So now we are going to, from next class, we are going to combinedly study these things. Okay, your homework question should be this. This is your homework. Note this down, please, right now. Time taking नहीं होगा बाबू, time taking नहीं होगा, करके देखो. You solve this. 3, 4, 4, 32 by 9. This is, it's given that it is a arithmetico-geometric progression. It is already given that it is an arithmetico-geometric progression. And you have to find the sum of infinite terms for this arithmetico-geometric progression. You have to solve it by assuming, by knowing, by believing that it is an arithmetico-geometric progression, even if you are not able to see it. Now, we'll start from this question. Remind me if I forget. Okay, this question will start from. This is your homework question. Note this question down. Don't look for the solutions for answers anywhere. Try to see the AGP over here. If you are able to do that, the sequence and series problems or recursion series problems are not going to bother you. It's okay, Kumar Rakshit, no problem. Okay, you can watch the recording. Okay, the series problems, the recursion formulas are not going to disturb you, right? If you are able to see the AGP over here. Okay, ji? Chaliye, we'll start from the next class then. Till then, take care, have fun, keep learning, keep loving math, keep loving problem solving. You are amazing people, you are smart people, and keep being smart by solving more and more. All right, thank you, bye bye, take care.